Hello friends, we will discuss new topic or new chapter which is known as chain survey. So let's start. Here, chain survey. We will discuss subtopic like linear measurement, accessories, chain correction, tab correction, and chain survey. And there is obstacle in chain, offset, and ranging. Offset formula is very most important. This is very most important. After that, this is very most important. Now, first subtopic is known as linear measurement. What is linear measurement? Linear measurement means who measures only one single distance is known as linear measurement. Like here is instrument used for measurement and methods. Okay, there are three types of method which are direct method or is known as done with the tap or chain, like pacing, steps counting. Pasometer means register the number of steps. And pasometer is a device which registers the number of steps. What is pedometer? Pedometer also registers the distance. Okay. Odometer, it's also measure the distance, number of revolution made by wheel or distance traveled. Is measured with the odometer and speedometer. We usually know that the speed measure. And chaining is the most accurate method of direct measurement. Chaining is chaining. In chain survey, there is a chaining method is the most accurate method in the direct survey only. Direct survey only. And next is optical, means use of optics lens. Okay, work on the principle of optics, like a tachometry. Okay, and the last is spatial instrument, electronic distance measurement. Okay, now we will go ahead. Like here, linear measurement, like instrument used for measurement. We have discussed about the direct, optical, and spatial instrument. Now we will have to done with the instrument. Like there is a chain. Okay, what chain? Chain. Use when accuracy not required too high. When we use chain, then we don't require accuracy. Then we usually done with a chain. It consists of ring and links made of 4 mm dia of milled steel. 4 dia का बना हुआ रहता है, ठीक है? To provide flexibility than galvanized iron. No, इसमें भी adjustment किया जाता है. If chain is too long, then closing joints of elongated ring, then reshape ring, remove small ring, replace warm out ring. ओके, जब टू शॉर्ट होगा तो फ्लैटरिंग करेंगे किसको, सर्कुलर रिंग को, फ्लैटरिंग द सर्कुलर रिंग, और बाय स्ट्रेटिंग द लाइंस, और एक्स्ट्रा रिंग प्रोवाइड, रिप्लेस रिंग टू बिगर रिंग। तो यहाँ पे एडजस्टमेंट हो गया। टाइप पहला, चेन के भी टाइप आते हैं। तो पहला है गंटर और सर्वेयर स्केल, सर्वेयर चेन। गंटर और सर्वेयर चेन में 66 feet is equal to 100 links, which is usually known as 20.12 meter. If we use engineer, then there is a 100 feet is equal to 100 links and 30.048 meter. Remember, this is the most important. Gunter, surveyor or engineer. Surveyor, engineer, gunter, gunter. गन है किसके पास? सर्वेयर के पास। गन हैविंग सर्वेयर, engineer don't require gun usually. Okay, now fourth one is steel band. Fourth one is metric, means meters. Okay, there is only two. First is 20 meter, which have 100 links. For each link, there is 0.2 meter. 30 meter also carrying 150 links. For each, they also carrying 0.2 meter. VVI, very important. For 5 meter and 10 meter chain, notch is provided at every meter. Notch is provided at every meter. For 20 and 30 meter chain, notch is provided at every 5 meter. And at every meter, brass ring provided. Okay, brass ring is provided at every meter. What you understand? In 20 and 30 meter, every 5 meter we will provide notch, and every meter we will provide brass ring. One link, if there is a one link, then we will give one circular ring plus two oval ring. Okay, this is a metric ring. Now the fifth one is steel band. This is also 20 meter and 30 meter used where accuracy is required. In chain survey, uh, in direct, in chain survey there is a method. In direct survey, we if accuracy required, then we will applied chainage. Okay, if higher than chainage, then we will do with the steel band. Okay, now we will uh, use the next instrument, which is known as tap, which is known as tap. Tap. Hmm. There are also many types of taps. You can see there is a cloth or linen, which usually have very less accuracy because of the affected by moisture or wind or natural environment condition. So we don't use this type of as where we require accuracy. And there is a second metallic, which is similar uh, like metric chain. Yeah, metric chain. Metallic 20 to 30 meter, reinforced by copper and brass wire. Okay, metallic is reinforced with a mm, copper and brass wire. Now there is a steel there, which is usually 10 to 15 meter. At end brass ring, standardize the chain. And the last one is the most important accuracy, where we require high accuracy, is known as inward tap. It is usually comes 10 meter, 20 meter, 30 meter, and 100 meter. Okay, 20 meter, 30 meter, 100 meter. Made of alloy, steel, and nickel. In war means nickel. Highly precise, low coefficient of thermal expansion, generally generally used for baseline measurement in chain survey, because baseline measurement is the highest precision which uh, close the boundary. Okay, so that's why we use the inward tap. The most important here is inward tap, engineer or surveyor tap, and metric. That's all. Now we will discuss about this next subtopic, which is known as accessories or equipment. So we will discuss accessory for chaining. Accessory for chaining, there are first accessory, peg. Peg, peg used to mark fixed point on ground, either temporary or semi-permanent. For permanent, we reinforce, like its height is approx 7.5 centimeter to 60 centimeter. The next one is ranging rod or lining a flag या poles. Ranging rod is made of galvanized iron, okay, of 25 dia or galvanized iron 25 dia or timber is 30 dia. Length usually 2 meter to 3 meter. And the third one is arrow and chaining pin. Arrow and chaining pin used to mark end of each chain. Dia is 4 mm, okay, and length is 400 mm. 10 arrow with one chain. Chain disclose of a point from a starting point. Okay, now there is offset rod. Offset rod as rod same as landing, but tape. It is open ring type hook. Length is equal to 3 meter. Used to state out offset lines at right angle. Offset rod, it is an open ring type hook. Length is 3 meter. Used to set out offset. Okay, which is used to set out the offset lines between the right angle. 3 meter length. Usually all offset rod means usually 3 meter. Okay, and there is a clinometer. What clinometer? Clinometer is usually used for the angle. Used to measure the angle of slope of the ground. Used for the angle of the slope of the ground. Mac, Mac, Mark. Mark is made on the ranging road at eye level. Then plum is for. Okay, like here is a ranging road. Okay, I am seeing here from with a clinometer like this. Then I will hit the pole. And then I will plumb fall here. This is not clinometer. Simple clinometer means angle measurement. Vertical plumb. Plumb made of steel in inverted conical shape like this. Used for centering and alignment in the direction of gravity. And nylon string is used. This is a nylon. This is nylon string. No. Now, equipment for measuring 90 degree means right angle. Okay, there is basically three. First is equipment. First is cross staff. Cross staff only. Also cross staff having three. First, open only measure 90 degree. Okay. There is a French octagonal brass tube measure at a 45 degree also. And the last is adjustable, which measures 360, measure any degree. Okay. And the next is optical staff. This optical staff is superior than the cross staff because principle double reflection of lights from two surfaces. Here we use cylindrical box of 50 mm dia optical staff. And there is a last prism square, which is more accurate than optical star. The only difference between the optical and prism star is no adjustment required because angle between reflection surface of the prism is kept at 45 degree. Mm. Adjustable measures of 360 are okay. The note and the final of this subtopic is I'm summarizing range finder. Whatever range, the established distance between 2 points, range finder. Sectant, which I said that to measure angle, sectant. And then last is set square, throw perpendicular, planimeter to measure area on map, pantograph for enlarging or reducing the plan. Okay, now we will go for the correction. There is two type of correction. First is chain correction, and the second one is mm, cap correction. Okay, we will do the correction. There is type of correction in chain correction. Okay. So first, correction of standardization and correction for slope. These both are most important. Okay. So first we will start from standardization. Standardization, like we know that or we require a length, then we will change into length upon length into length. Okay. The correction factor is this is measured length. Change change in length upon original length will do measured length. Okay. Correction is equal to, or we will, this is also called correct, correct, wrong, wrong. Okay. Correct, correct, wrong, wrong. Correct, correct, wrong, correct, correct, wrong. So, first of all, change in length. We have to do this. Means this is the universal. Only learn this formula. Okay, then correction. What is correction? Correction is original length minus change. Means true value minus measure value. Okay, true value minus measure value. Now, put value of L. If we put the value of L in correction, like here will be, this is the L value. L upon dash upon change length upon L into L dash minus L dash. Then we will get this L dash upon here this. If we put the value of L dash, like transfer L dash up in the denominator of the original length and this upon to the, okay, then the formula will become this. This is also correct and this is also correct. Here is original length, mm, okay, which is true value, true value. Here is a measured measured value. Both are correct. There is an error. We calculate the correction and then we have to reverse, like measured value minus true value is known as error. The same thing happened here also. Like this is the most important, which is in green. Okay, the current length is equal to change in length upon length is equal to measured length. If there is an area, then length change into length upon original length into a square is equal to measured area. Then similar to the volume, there is a cube. Okay, now like as true value, measure value, correct length of line is equal to incorrect length of chain upon correct length upon measured length. As similar as a chain. Now we have done this. If true value is greater than correction will be always positive, means true value means original. Okay, measure value means we have calculated. Measure value means usually a wrong. Okay. Now We will discuss about the correction for slope. Correction of slope, always negative. Remember S or S means donkey. S, brother of donkey. S. Okay, I can write here. I will write. Remember the formula. Here, if the theta less than 30 degree, less than 30 degree, then slope correction ignore. Okay, correction true, correction D minus A. Only remember this. I have derived this, but we only remember the correction slope is equal to minus hypotenuse square upon 2L. Now measurement by chain on sloping surface. There is a direct method which is known as stepping method, and there is a indirect method. Indirect method, when angle of slope is known, vertical distance between 2 points is known, first angle known, second 2 points known, and the third by hypotenuse allowance. This is the most important. Okay, hypotenuse allowance. And hypotenuse allowance, see, correction of hypotenuse is equal to L bracket sec theta minus 1. Sec theta minus 1. Sec theta minus 1. Okay. L stands for length or meter. Theta is degree. We usually know. So hypotenuse, most simple formula is L upon sec theta minus 1. Sec theta minus 1. Then second is, if we given radian, then how will we find the hypotenuse? Correction for a hypotenuse. We will find L upon theta square upon 2. Okay, that's the only formula. If there is also given a degree and hypolinks, means degree and length, then we can multiply by 1.5 theta square upon 100. Okay, then why we use the first one and why use this one? The both are the same. This is usually for lengths, and that is lengths and meter. Okay. And the last one is slope is given in 1 in n. 1 in n. Then we have to L upon 2, 1 upon n square. Length or length divided by 2 and 1 upon n square. Note, there is a tension applied of 8 kg, which is known as 80 Newton, end of the chain at a standard temperature. T is equal to 20 degrees Celsius, then tolerance plus minus 2 mm at every meter length. Overall accuracy. Like for 30-meter chain, there is a plus minus 8 mm permissible error. Okay. For 20-meter chain, there is a plus minus of 5 mm. For 5 meter or 10 meter, there is a plus minus of 3 mm tolerance, which is permissible error. For every 1 meter of chain, there is an allowance of plus minus 2 mm. You have to remember like this: 1, 2, 3, 5, 5, 20, like this. 1, 2, 2, 3, 3, 5, 5, 20, and 30. And similarly, learn below like this: 1 meter, 1 meter every plus minus 2, for 5 or 10 meter every plus minus 3 mm, and then 20 meter the plus minus of 5, and 30 meter there is a plus minus of 8. Remember, you have to write every day. Then you will write. Then you will learn. Like, I also don't remember. Like, no. What for every 1 meter, how many? Plus minus 2 mm. For every 5 or 10 meter, plus minus of 3 mm. For every 20 meter, plus minus of 5, and 30 meter, there is a plus minus of 8 mm. Permissible error. Okay, permissible error. Overall accuracy. Okay, okay, accuracy. Now, and what about the hypotenuse allowance? Like hypotenuse allowance, there is a formula L sec theta minus 1. Okay, and there is also 1.5 radian square upon 2. Sorry, 100. There is L upon 2, there is L upon 2 in 2. Okay. In the formula, there is two formula carrying L upon 2. We have only multiply by theta square, or L upon 2 only n upon 1 upon n L square. And there is a 1, which is L sec theta minus 1, or 1, 1.5 theta square upon. Now, the tab correction. This is the most important from chain survey. Like in the chain survey, here is also a correction of the standardization, correction of slope. Both are same in chain as well as in tab. Both are same, but here more are as similar as chain. We have discussed, so we don't discuss here. Only remember the formula: hypotenuse square upon 2L here. And for correction of standardization, we know the formula like L, like L is equal to L dash upon L into L dash, which is known as measured value. Okay, then we have to apply the correction value like True value minus measured value. Okay, correction. Now, the third one is the correction due to the temperature. We know that the coefficient of thermal expansion, which is correction of temperature is equal to length of the measured length, coefficient of the thermal proportional into the change in temperature, which is Tm minus T naught. Tm is the temperature at measured value, then standardized value. If temperature is measured value, there is a T naught is the temperature at the time of standardization. Okay, as similar as the correction due to the pull, means change in a length. PL upon A, we have to change PL. P means force. Force when we applied, then minus to the standardization. If the measurement is greater than a positive, if the measurement of PM is less than a negative. Okay, the most important in this is correction for slope and correction for sag. Like I will write here, what A double S, okay, negative only, negative only. A for wrong alignment. A for S for slope. Sometimes it's heavy, like alignment plus slope and sag is known as S. The brother of donkey, who is S, always negative. Okay, you have to remember the formula. W square L is equal to 24 P M square, means pull. We have to pull. This is a catenary or parabolic profile, sagging due to the self weight. Measured value correction is equal to true value minus measured value is always a negative. And the last is correction due to the wrong alignment, as similar as the correction of for slope, but we have to turn twice. Here is important for correction for sag, correction for slope, and correction for alignment. As and they are not that much important, but remember, you can You know that correction change in length and correction change in temperature. This is new correction for slope, hypotenuse square to L. Okay, now I'm going to the last and final chain survey. What is the principle of chain survey? Okay, principle of chain survey are there. Area is divided into the number of well-conditioned triangle, which is known as triangulation. Okay, chain survey principle dividing the area into the number of triangle, which is known as triangulation. And the second is side of triangle are measured in the field for locating the details offset are taken. For doing the chain survey, we have to do offset. What we have to do? Offset. That's why the important offset. Offset means 90 degree. Step in chain survey. The next. What is well conditional triangle? There is a three type of triangle. Ideal triangles, which is known as equilateral triangle, having the 60 degree angle at every three. And the second is well conditioned triangle. Uh, the theta not less than 30 degree and not greater than 120 degree. And sharp end or apex, so data point locate easily. But in ill condition, there is a no. They are telling that theta can be less than 30 degree or theta can go greater than 120 degree. This is not valid. Okay, you have to remember only two well conditioned triangle only. Now, steps in chain survey. First, recognize survey means refresh, sketch, prepare. Here, refresh, sketch, prepared. Then, fixing and marking survey station. Fixing and marking the survey station. Then, running the survey line. Then, setting out offset. Okay, this was the principle. Now, now, there is offset. Okay, offset means lateral or perpendicular. Okay, like here is a building here is a building. Okay, here is a building. Here is a building. Or here, like we draw like dot dot dot. Then we draw like a dot dot dot. Then offset in between. We get this is known as offset perpendicular. Okay. Short offset is equal to length less than 15 meter. 15 meter. Limiting length not less than 0.025 centimeter. There is a perpendicular and oblique. Perpendicular offset perpendicular to survey a baseline. The oblique is inclined to the baseline. Perpendicular is for short measurement and oblique is a measurement, long measurement. To avoid long offset, tie line used to check accuracy. Taken from corner or wall for building for more accurate. Taken from corner or wall of the building for more accurate. Okay. Mm. Okay, we have done with limiting offset. Will be next topic is only fully offset. Okay. There is a IS 491 linear measurement, only horizontal plane, less crowded, flat area required, small area with less detail, heavy to carry. Instrument are heavy to carry. Okay. The reference sketch or iconage is drawn tie line. This is important. Tie line. The line joining tie station or tie line for taking offset from it. Check line. The line joining the apex point of triangle to fix point on its base. To check accuracy of triangle or the line joining the vertices of triangle. Survey line or chain line. The line joining a main station is not survey line or the chain line. Base line. Divide line into two equal parts. Proof or check line. To check accuracy of the field. Subsidiary or tie line. Line joining two tie station. Tie line join tie station. Major survey line. Line joining two station. Main station or survey stations. Starting and ending point. Registration decided upon your survey. Check line. Always remember check line and chain line. No, chain line. Only remember tie line and check line. This is the most important. Okay. Tie line and the check line. Tie line, the line joining tie station. Tie station. This is tie station. Okay. This is tie line. Now, topic is offset. What is offset? A lateral or perpendicular, I usually told. Method to draw offset, perpendicular offset. There is three method. First, swing the tape or arc line method. The second is 3-4-5 triangle method, and the last is chain builder square, having a uh, having a like a right degree. We have to put and line this. Then it is not a square, building square or builder square. The second is we have talked about method to draw the perpendicular offset. Now, there is a limiting length of the offset. This is the most important of the offset. Limiting length of offset. Offset net not to be long. Displacement of details on drawing less than 0.25 mm or 0.025 centimeter. Okay, depends on the scale of the plot. This desired level of accuracy, error in direction of offset and length of line. There is two offset along the chain and displacement perpendicular to chain. Along in the chain, there is a limiting length of offset. Length is equal to 0.025 s upon sine theta. What? Length is equal to 0.025. Length is equal to 0.025 upon Sine theta is 4 and there is a length upon 0.025 minus cos theta. Okay, this is for along the chain line. This is displacement perpendicular to the chain line. Perpendicular to the chain line and along the chain line. Only difference is the sine theta. If there is a question, in general, a scale is 1 centimeter is equal to S meter, but in some problems, scale is given as 6 centimeters is equal to 36 meter. 6 centimeters is equal to 36 meter. Then we will apply 1 centimeter as 6 meter. Then S value is 6 meter. Then will be applied L is equal to sine theta 0.025 S. 0.025 as value is 6 sine theta. I don't know. Right now. Got it? This is the most important. 0.025 is a usual as if they are given in question 0.030 sine theta. That then we will do with this. Okay. Short lengthening perpendicular oblique. Now if this is also most important. Note if the accuracy of survey work is 1 in R, then for 1 meter the length of offset error in linear measurement. Okay, we have to find error in the linear measurement, which is um, uh, R measurement means error meter is equal to 1. Means definitely there is 1 upon R. Okay, if the accuracy of survey work is 1 upon R, then for 1 meter. Then for 1 meter length of the error means for 1 meter there is a 1 upon R. Okay, simply. For 1 meter, direct question for 1 meter, we got 1 upon R. Okay, then I got 50 meter. Then 1 upon R into 50. That's simple. Got it? Got it. Now, ranging. First of all, what was that? So along was 0.025 into S upon sine theta perpendicular 0.025 into S upon cos theta 1 minus cos theta. Is it right? Let's see. 1 minus cos theta 1 minus cos theta. Right. Now it's the last of this topic We are concluding them. We will summarize. Okay. In ranging, there are two methods: direct ranging and indirect ranging. In direct ranging, in the station are intervisible, minimum two ranging rod required. But in indirect, minimum three ranging rod required for the interpolation. Like uh, station A here, station B here. Okay. In a mountain, we have like this, and the person see here. If he see here, then he's also see here. This is indirect method. Indirect method, like a straight path, which is required A person, B person directly. Then is known as okay. What are the obstacle in ranging and chain? Chain is free, but vision is obstructed. And chain are free, okay, but vision is obstructed. Forest, mountain, okay. When chain is obstructed, but vision is free, means we can't use chain. That's why chain is obstructed. So river, vision. We can see the river here and there, but we can't use a chain. We have to do offset of perpendicular or we take and time triangle or hypotenuse. Now, and the last one is when chain and vision both are restricted. Okay, like obstruct building or structure of building. We can't see and we can't move the chain to measure inside. And the last is establish intermediate point. What is ranging? Ranging is known as the establish intermediate point on a straight line between two endpoints. Okay, ranging is intermediate point helping to the two main station. There is two things by surveyor to the assistants. Like surveyor slow sweep with the right hand, means sweep right hand. They are sweeping right hand like this sweep. Then the assistants move your left. If the surveyor moves sweep to the right, then the surveyor will move to the left. Okay, are you getting? And then next, if he do with a rapid, means fast, then assistants have to move rapidly also. But now, by surveyor, both hands above head, then brought down slowly. Means both like this, then down slowly like this. Brought down slowly like this. Okay. Then assistance ranging is correct. Assistant ranging is correct. Then and the last, both arms extended forward, horizontal and hand brought down quickly. Both arm extended forward. Means forward like this. Okay. Then suddenly fall. Means fix the ranging rod. The assistant have to fix the ranging rod. This was the ranging chapter. And the formula of the this is we already know this. Okay. Correction. Okay. offset also made this. We will discuss the numerical portion in the next coming video. I have completed the second topic, which mainly most of the teacher will take required 3 hours. I am taking this all in one. So revise this properly. See you again. Bye.